Hello, this is Mr. Brown. This podcast is for the CNT140 for your bid spec. Let's dig into what we need to do for our catchment area. We've met and we talked about our building, and you've walked through your building to find out what rooms are being used for what. We called that our site survey. So now you have a map of your building that has marked down this is classroom, this is lab, and we found some potential closets. So we now need to, before we spend too much more time, do what's called a catchment area, where we're going to find out if that closet will work to cable our hallway. So I'm leaving this up for reference for our rooms for our building. I'm going to shift over to our other notes page. Reminder, if we go to the content page of D2L, I have a bid spec page, and in here I have general files with maps of your buildings, and I also have note pages for things like catchment area and so forth. So I'm going to be referring to those pages. So I'm going to pull up my catchment area, and what we need to do after we've done our site survey, we need to remember a couple things. Twisted pair can go 100 meters unboosted, but really if we remember our cabling structure, our horizontal cabling is 90 meters, the other 10 is patch cables in each end. But when we're estimating, we really estimate 50 meters from our closet out to rooms, because we have to go around corners, we have to go up walls, we have to come down walls, we have to go on obstacles. So when they're estimating, they do basically a 50-meter radius from the closet to see will the cabling reach a room. So that's kind of our ballpark. We'll learn in a later chapter why that is, because of orthogonal wiring. And here's the reason. As I'm wiring my building, I'm going to leave my closet, head down the hallway and into the rooms, and we're doing lots of right angles to go around obstacles and to make it easy for routing. So the ballpark is I've reduced by about 40% when I'm estimating. So that's about 50 meters. So we're going to do a 50-meter radius from our closet. So what we need to do is some quick math to estimate our 50-meter radius, because what we ultimately want to do is take our building, grab a compass, and basically strike an arc of a 50-meter radius around our closet to see anything in the radius cabling should reach that room. So we'd easily be able to cable these rooms. There's no way I could leave this closet, come down these hallways, and come way over to here. There's no way. It's way outside the radius of that. So this gives me a quick ballpark of, can my closet handle cabling ABC room, if you will. So let's do some quick math. All right, let me slide this away. And let's remember, in our buildings, we'll pick on Hall Tech for a minute. On Hall Tech, we have a 1/4 inch equals 8 foot. Well, we need to estimate 50 meters. So let's figure out 50 meters in feet, so we have kind of apples and apples, if you will. So I'll use the Google conversion here. 50 meters equals 164 feet. So we know the scale of our building, we know we need 164 feet, so let's do some quick math to figure that out. Here's my example. If I have 1/4 inch equals 8 foot on my map, 1 inch equals 32 feet. That's the same, scale, if you will. I just increased it, so 1 inch equals 32 feet. And we know 50 meters is 164 feet. Well, we need to find out how, oops, Mr. Brown, a little typo there, how many inches on our map equals 164 feet. So we're going to do a simple ratio proportion. If 1 inch equals 32 feet, then we're not sure how many inches yet, so that's x, equals 164 feet. So we do some cross multiply. 32x equals 164. 32x equals 164. So we divide both sides by 32. X equals 164 divided by 32. When I do the math, x equals 5.125 inches. So what it amounts to is, on my Hall Tech building, I'll set our compass to a 5.125 radius to check the catchment area of my closet. So I would then get that out of the way, go back here to this. I would then, on my map, use my compass and strike a 5 1/8 inch radius from my closet to say anything inside that radius will be able to be cabled. And the ballpark for me is, if I look at this and most of the room is being covered by the arc, we should be in good shape. But if I only have the tip of a room, if the arc only comes through this very corner, I'm probably not going to be able to cable the room. So we're looking for a quick estimation of, will it cable the rooms? Will the cable reach those rooms, or are we going to be beyond the 90-meter radius? So we're looking pretty good. That would be pretty good. The next thing we need to do is start converting this or use a spreadsheet to help us calculate how many feet of cabling we need to do for a room. So we're now going to do some estimation. What we'll do is we will actually use a ruler and measure the distance from a closet to our room, straight line, and then we will take that measurement, plug it into a spreadsheet, and have the spreadsheet do all of our math for us. A heck of a lot easier than measuring this little piece, then this little piece, then this little piece. So we're actually going to use just a straight line measurement here and plug it into a spreadsheet, something like this, that will calculate our distances for us. So let's real quickly create a spreadsheet that would do some of this for us. That way I can get you up to speed on your spreadsheet. So I'm going to open up my Excel over here, and I started to plug a couple things in. I'm going to want to have a column for a room number. I want to have a column for room use. Room number will be something like 101. Room use would be something like C for classroom, L for lab kind of deal. We're going to want a column for the measurement in inches that we're going to measure on our map. So if we measure it to be 2.5 inches, that would represent that. Well, let's start doing a couple formatting things here that'll help. I'm going to highlight this line. I'll do a bold because those are column headings. I will do, come on there, Microsoft Excel. I'll do a center, and I'm probably also going to want to have some word wrap here. So I'm going to format these cells as well to do word wrap on this. So I'll do a format cell, and then I'll select my option here for, I believe it's alignment. I'll wrap my text, and that way all my header's not going to get really wide. My column header's not going to get really wide. So we have room number, we have use, we have the map length in inches, and we want to convert that to feet, if you will. So one of the next things we'll do up here, measured distance of the room, we want to convert that to feet. So we go back here. We want to convert this to feet. So let's do something like real distance in feet or something like that, a real distance, and we'll put a reminder of feet. Well, to do that, we're going to do a quick formula here. So we're going to do equals, and we're going to put a formula in that says take whatever is in this cell. So I'm going to click that, and you'll notice in the top bar it puts the cell in, not the number 2.5, and we're going to multiply by our factor. Well, if I go back to my notes page and remember, let's see, I'll pick on Whitaker this time because that's the different map, if you will. Whitaker is a 1/4 inch equals 12 foot. Well, 1 inch then would equal 48 feet. So if I take that over here and say multiply whatever this is by 48 feet, because we're measuring everything in pieces of an inch or fractions of an inch, so it basically says whatever is here multiply by 48 feet, because 1 inch equals 48 feet. That should take this and convert it into real distance in feet for us. So I'll hit the enter key, and now if I change my distance over here, you'll see it's calculating the distance in real feet in this column. That's what we want. Again, here's my formula real quick. I'll put an equal sign here. I'll highlight this cell, do the asterisk for multiply, and do 48 feet. And there it is for me. And what I can do now is if I highlight this cell and grab this little square in the corner and drag it down, it copies that formula down to these cells here. So I can now go room 102, room 103, and I can do, again, classroom, and I'll do something like 3.5 and 4.25, and it's converting to feet for me. Woohoo! We now need to, I'm going to do a quick save on this row before I get too far. Put that on my documents, and I'm just going to call this bid spec spreadsheet at this point. Alright, now we need to, once we've converted to real feet, we also need to, let me get the right page here, we need to add our 40%. As we talk in a later chapter, when we route orthogonally, we measure a straight line distance. We're going to measure a straight line distance, but we need to account for the cable to basically take right angles as it's going down the hallway. So to do that, we add 40%. So we'll take this column and we'll do the, I'll just call it like add 40% to that for our wiring. So for this one, Again, we're going to add another formula. We're going to say equals whatever's in this cell. We're going to multiply by not 0.4. That would be 40%. We don't want 40%. We want to add 40%. So we need to do 1.4, which would be 140%. We'll take whatever was here, 100% of it, and we'll add 40%. So there we see, we add this right here, and we've added 40% to it, and it gives us 201 feet. Again, I'll highlight that cell, drag it down. It's copying that formula down for us. Woohoo! So we've added 40%. Next thing we need to do is we want to have a column where we multiply by the number of drops. Because again, one room will have 12 drops in, one will have 6, whatever. So we will put a column here for multiplier. So we're going to just say room quantity, something like that. Room quantity, quantity of drops in room. We can put something like that too. Quantity of drops in room, something like that. So now as I put these in, say, okay, a classroom gets 12, classroom gets 12, classroom gets 12. You know, maybe down here we're at 104, and this is a lab. This was 3.75, so this one gets 24. Okay, that allows us to multiply whatever this distance is for one cable run by the number of cable runs will really be in that room. So now we need a total column over here. If we take a look, number of drops per room, and now we need a total cable needed for the room. So we'll put a column here, total cable for room. And now what we're going to do is we're going to say this column equals whatever this was times whatever this is. Okay, again, I'll clear that out. I'll take this column and I'll say equals. This column, I'm clicking on it, asterisk, and I'm clicking on this column here, enter. And that'll give me a room total, not a cable I need to cable this room with all those cable drops. Highlight the cell, drag it down. That's copying the formula down for me. And all I would need to do at this point, obviously save, I would need to continue down my hallway, room 105, 106, whatever it is, you know, office, and just continue measuring on my map, converting to here, 4.5, 3.5, and it's going to do all the calculations for me. Office gets 2, office gets 2. And once I'm done with my whole hallway, down here at the bottom, I will need to put a total. So I'll highlight here, maybe I'll put something like total. Oops, if Mr. Brown can type. Total. And what I'll do is highlight that cell, and I'm going to look for this little squash D. That's a sum, if you will. I'll click on that, and it's going to say, hey, do you want me to total up all of these? Sure. And I could click and drag this to include what I wanted and what I didn't. I'll say sure, hit the enter key, and it's going to give me a total for this whole column. 15,000 feet, 15,792 feet of cable I need. And now that would give me an idea. When I buy cable, it comes in 1,000-foot spools, so I need about 16 spools of cable so far. A lot of cable. But that gives me a way to estimate how much cabling I need. So you'd want to do this for your hallway, and probably the best idea is do this for one hallway, leave a space, copy this down again for your second hallway. That way you have a new chart for the second hallway. That's going to help out later, because as we organize and buy things by closet, you'll want a quantity for this closet, and then a quantity for this closet, and this quantity for this closet. So there's real quickly how to do our catchment area spreadsheet. So I'll save that, and what I'll probably do down here is even change my label of this to cable estimation or something like that. And then later on we'll be able to put other things on the other sheets, like the equipment list and patch panel layout and that sort of thing, and I can keep it all in one spreadsheet. So I'll save that. I'm going to pause for a quick second and pull this out of the way. We're going to also want to, once we start doing this and we kind of get everything measured out, we're going to want to take a minute and start drawing on our maps like so. So we're going to want to take our map of our building. I'm going to pull up Whitaker here. I'll open with paint, and I'm going to want to start drawing on here to show, all right, let me pick this here, and I'll pick a shape here, and I'll say, okay, this is my closet. I'll put a label over here that says, okay, that equals closet. So now I'll put next to it, and I'll say that's my HC, and so forth, to start showing my building. I'll give you some more details on this in another podcast.